Hey guys, welcome to the second part of this course. It's going to be a little abbreviated this year, but we're going to hit the topics that are going to help us to answer kind of some of the prediction type questions mathematically. So I asked you to predict the number of COVID cases you thought there would be in the US and in the world by May 1st. Going to try to teach you some things here to give you some tools to be able to approach that in a more mathematical way. Some of you did, many of you, it was just kind of your guess, and that was fine. So to do that, we're going to look at what we call mathematical modeling, and this is one of the Common Core math practice standards. This is the way that students are supposed to be learning math. They're supposed to be thinking like mathematicians. They're supposed to be modeling real-life scenarios. And I want to point out there's a slight difference between mathematical modeling and modeling mathematics. So here's an example. If Susan has 5 apples, she gives two of them to Alberto. How many does she have left? If I was going to model this real life scenario with mathematics, I would probably take 5 minus 2 equals 3. And this is modeling a real life scenario with mathematics. It's mathematical modeling. I've taken the real world and I've used math to describe it, to model it. Now, especially in elementary school, we tend to teach math by modeling mathematics. So you might say to a young child, hey, 5 minus 2, I want you to draw out 5 circles, and then we're taking away 2. And so we're crossing off 2. So my answer then is 3. Here, we've actually modeled the mathematics. Do you see the difference? Here, we've modeled the mathematics with manipulatives. Here, we're modeling a real-life scenario using mathematics. And so that's just kind of a side note that I wanted to share with you. So let's take a look at 3 real-life scenarios. The first is that Bryce earns $20 for each yard he mows. The second is everyone in a class gives each person a high five, and make sure to wash your hands afterwards, right? We did this problem earlier in the course, and so I thought you would remember that. And then I have some strawberry plants in my garden, and I don't know if this is actually accurate, but pretend that each strawberry plant, it grows, and then as it grows and matures, it puts off little runners. So you end up with, okay, I'm a horrible artist, but here's a little strawberry plant. What it does is it shoots out little runners. They actually are kind of greenish red. And then a new strawberry plant grows there. And so I'm saying, let's say hypothetically, each strawberry plant puts out 5 runners and grows 5 more strawberry plants. Even green and red like strawberries, huh? All right, so each of these scenarios I'm going to look at a little bit closer. Let's take a look here. You can imagine if Bryce is mowing yards, we say if X is the number of yards he mows, Y is the amount of money he earns. If he mows 0 yards, he makes $0. He mows 1 yard, he makes 20, 2 yards, 40, 3 yards, 60, and so on. That makes sense, right? Okay. Now, let's take a look at if we graphed that. Okay. So, excuse me. All right. Let's say we graph that, and so I've already done that, and I want to highlight it here. I went 0 to 200, and I'll show you why here towards the end of the video. But each time he mows, it goes up $20. Okay, up another 20, up another 20, up another 20. And so we get a graph that looks like this. If you remember with the handshake or the high five problem, when there was one person, there's nobody to give a high five to, so there's 0 handshakes. When X is 2, there's 2 people, there's 1 high five exchanged. 3, there was 3 high fives. 4, there was 6. 5, there was 10, and so on. And so you'll notice this is a little different. Here it was going up by 20 each time. Here it's going up, but it's changing. It's from 0 to 1, 1 to 3, 3 to 6, 6 to 10. It's going up by more each time. And this graph I didn't care for quite as much how it turned out because it really starts out slow, right? We've got 0 here, and then 1, and then 3, and then 6. But with the way I've scaled the axis, you don't really hardly see that change. It almost looks like a line, but you can see from our table it's not a line. All right, now the strawberry plants, I didn't think about this, but it worked out. All right, this gets us slightly more complicated, but if you take a look, if X is the number of generations we've had, and Y is the number of plants, let me explain. So the first generation would be this plant. Then after that plant has its new plants, then that would be considered the second generation. And so if we're still on the 0 generation, maybe I should have adjusted these, but let's just say 0 generation is 1 plant. So I'm going to come back over here. I'm going to call this the 0 generation. This is the first generation. So at 0 generations, we have 1 plant. After 1 generation, we have 6. Do you see 1, 2, 3, 4, 5, 6? Okay. And then after the second generation, we're going to have 36 plants. I don't know if you can imagine this, but this one will add 5 more, so there'll be a total of 6 here. This one will add 5 more for a total of 6, total of 6. This one will add 5 more for a total of 6, total of 6, total of 6. So you see we have 6 plants that all result in 5 new ones plus itself, which is 6. So a total of 36. And each time you see this is going up. So it's going times 6, times 6, times 6, times 6, and so on. And so when you graph this, you can see it goes from 0 to 1 to 2 to 3. And so maybe I shouldn't connect these because there's no in-between values, but I'm going to just so we can see the shape of these curves. But you see this one starts off a little bit slower and then takes off. This one starts off really slow compared to that one, and it takes a while to take off. Now it will eventually curve up quicker, but it is going to take a while. In fact, probably not even that quick. It's probably going to come out even more before eventually it will come up. I think when we did it in class, if I remember right, if there were 20 people in the class, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, you get the idea. I think there was 190. And so, wow, that really is pretty slow at first. Okay. And then this one, we can see takes off in a straight line. And that gives us, okay, so let's just pause here. Let me do a quick review. So why am I doing this? I want you to think about mathematical modeling, and I want you to think about how scenarios are different. Here it's going up by 20 each time, and so we get a line here. Here it's increasing, so the line starts off really shallow, and you'll just have to trust me on this a little bit. Eventually it's going to curve up. And so that change is increasing each time. So it's going up by 1, up by 2, up by 3, up by 4. And so instead of being a straight line, that straight line is going to eventually curve upwards. Okay? So it's going to take a long time, but it really will eventually, when you go from 20 to 21, it's going to add even more. 21 to 22, it's going to add even more. And so it's really going to go up. And then we have other things like this strawberry plant where it's just exploding, okay? And so mathematicians, when they're modeling real-life scenarios, one thing that's really helpful is to look at how are things changing, okay? So here there's constant change, and when there's a constant change, we call that a linear graph. When that change is changing each time, so it's going up by 0, or up by 1, up by 2, up by 3, but it's not multiplying, down here we're multiplying, Often, I should say, at least in this scenario, we call that quadratic. Okay, so this is, first one's changing linearly, second one's quadratic, and the last one, you probably have heard of this, it's growing exponentially. Okay, and so in this first section, you're going to be looking at 4 different kinds of functions, and you're going to be trying to identify from the equations. I guess I skipped over the equations, didn't I? Wow. Let's take a quick look. Bryce here, his equation would be y equals 20x. Uh-oh, I forget this one. I think it's, well, we could take x, the number of people, times x minus 1 divided by 2, I believe. Does that work? So when there's 4 people, we take 4 times 3 is 12 divided by 2 is 6. When there's 5 people, 5 times 4 is 20 divided by 2. And so if I multiply this all out, I'm going to get 1/2 x squared minus 1/2 x. Okay? And this last one here is y equals 6 to the x. And so hopefully you can see that linear functions happen when things are going up constantly. We get a straight line, and we get an equation like this. Y equals, you're familiar with mx plus b. In this case, b is 0. Quadratic, you've probably seen before as well. It's more of a U-shaped if we would have the negative side of the graph, and it's got an x squared in it. Exponential, y equals 6 to the x. The x is in the exponent, and that's why it's called an exponential function. So that is going to pretty much wrap this up. Real quickly, I want to mention you're going to do a penny circle activity in Desmos, okay? And so really it's just a mathematical modeling scenario. It's going to give you a real-life scenario, kind of like I've given you here, and it's going to ask you to predict, is it linear, is it quadratic, or is it exponential? And you have to decide. Now, one thing, as you're going along, they're going to give you an equation, and you can see it in the graph, but I want to highlight that in that equation, x is the diameter of the circle, and y is the number of pennies. So take a look at that activity. I think you'll find it interesting. You can skip the question about would you rather have pennies or nickels if you would like. So hope that makes sense. I know there was a lot there. Let me know if you have questions. Thanks.